Alright, so using a t-test is when you're going to test the differences between two means. Your null hypothesis is saying that the mean of population 1 is equal to the mean of population 2, or saying that there's no difference between the two of them, right? This is the Greek letter mu, which is going to stand for the population mean. The formula for that is, remember, it's a t-test, so you're going to come up with the t-value. It's going to be the absolute value of the mean of population 1 minus the mean of population 2 over the square root of your standard deviation squared, or the variance, divided by n of population 1, so the number of samples you have in population 1, plus the variance of population 2 over the sample number for population number 2. Looking at that, you also have degrees of freedom of n plus 1, or n1 plus n2 minus 2. So it's kind of just n1 minus 1 plus n2 minus 1 to get you to your n plus minus 2. Okay. All right. So here's our example. We have some milkweed plants that have been grazed on by caterpillars, and we're saying that they have the same alkaloid content as ungrazed milkweed plants. So when a caterpillar chews on a plant, it's not going to increase its alkaloid content. Alkaloids are kind of like an insecticide. It helps to prevent grazing. Our alternative, of course, is going to be that grazed milkweed is going to have a higher alkaloid content than ungrazed milkweed, or doesn't have the same. They're going to be different. So if we look at this example, here's our grazed plants. These are micrograms of alkaloid per leaf tissue. And you get 3.4, 4.5, 3.6, 3.7, and 3.9. The mean of this group is going to be 3.82. And then the standard deviation, so the S value, is going to be 0.421. If you look, we keep the same significant figures, so 3. All right, and then for the ungrazed plants, we get 2.8, 3.4, 2.9, 3.1, and 2.8. Standard deviation and mean for this group is a mean of 3, standard deviation of 0.255. We go down here to our formula. Let's just move over here. So here we can see our means and our standard deviation. So mean of the grazed plants minus the mean of the ungrazed plants. You're going to take the absolute value of that, which means it's always going to be a positive number. And you end up with 0.82. So we could flip this. We can have the ungrazed plants here. We could have 3 minus 3.82, and you will still get 0.82 because we are taking that absolute value. So it doesn't matter if you have x1 or x2 where you have them. If one's bigger than the other one, it doesn't always have to be bigger minus littler because you're taking the absolute value. You're going to end up with the same answer. And then we have our S of 421 squared divided by the sample number, which was 5. And then over here, again, 255 squared divided by the sample, which is 5. And here you can see those numbers, 0.354 and 0.0130. Add those together, you're going to get 0.0484 square. Take the square root of that, and then 0.82 divided by that square root will give you something close to 3.726. Try it using these numbers and see if you come out with something close to 3.726. All right, so we have our calculated value for our t. We know our degrees of freedom, so N1 plus N2 minus 2, because we have 2 sample groups, right? Gives you your degrees of freedom of 8. We're going to use P.05. So the T-crit for 8 degrees of freedom at 0.05 is 2.36. Our T-calculated was 3.726. So our calculated is greater than our T-crit, so we reject the null hypothesis. So we're saying that there is a difference between these two groups. Here is another example that you can try on your own. We're looking at aerated ponds versus unaerated ponds and the growth rate of fish. Is there a significant difference between these growth rates? State your null and alternative hypothesis, perform a t-test. You don't have to turn this into me. I just want you to practice it. If you want to send it to me and be like, did I do this right? By all means, send it to me. Alright. So for your quizzes, know the meanings of a null hypothesis, of an alternative hypothesis. Be able to devise your own null hypothesis for a given experiment. Also, come up with an appropriate alternative hypothesis. Remember, the null is always saying there's no difference. Alternative is saying there is a difference. Be able to calculate your degrees of freedom. Use a statistical table to find your critical value. Know the meaning of the p-value. It's talking about the probability, right? Know how to interpret the results of a statistical test to either reject or fail to reject the null hypothesis. And then, given a formula for a t, be able to perform a t-test and draw the appropriate conclusions. So I will always give you the formula for the t-test. You do not have to memorize this mess. Okay. That is it for the t-test. This next one we'll be talking about correlations.